simplify the expression if possible. Assume x and y can be any real number. We have here the cube root of something, 64 times x to the 6 times y cubed. To simplify that, what I would like to do is to view this part underneath the cube root as something cubed. If I can figure out what I have to cube so that I get 64 times x to the 6 times y to the third, so if I can find the thing that I need to cube that equals that, then the cube root of 64x to the 6y to the third, this cube root of this thing that I cubed to get 64x to the 6y to the third, the cube root and that cubed cancel, and we're left with just that inside bit. That's telling me that this thing is the solution to what is the cube root of 64x to the 6y to the third, right? What is the thing that I have to cube so that it equals 64 times x to the 6 times y cubed? So if I can view it as something cubed, I have my answer. So let's go ahead and try and do that. Let's look at erase. Let's look at the factorization of these pieces, 64 x to the 6th and y cubed. X to the 6th, of course, equals x times x times x times x times x times x. Y cubed equals y times y times y. 64, we might not know off the bat that 64 is 4 cubed, but we could figure it out. We probably at least know that 64 is 8 squared, right? So 8 times 8, and we know that 8 is 2 times 2 times 2. And this other 8 is 2 times 2 times 2. And so if we view it in three pieces of equal size, 2 times 2, 2 times 2, and 2 times 2, we see that 4 times 4 times 4 is equal to 64. So 4 cubed is 64, y cubed is y cubed, and just like we did with the 2's, if we pair our x's together, we see that x to the 6th is y squared cubed, right? So here are the way to view each, there it is, 4 cubed, y cubed. Here are the way to view each of our three pieces as something cubed. So let's go ahead and rewrite this slightly. Cube root of something cubed. What do I have to cube? Well, I have to cube 4 and y and x squared. 4y and x squared. When I cube this, I get a 4 to the third, I get a y to the third, and I get an x to the 2 times 3, x to the 6th. So that's what I get in there. So now that I have this viewed as the cube root of something cubed, I know that my solution, that cube root, is just 4 times y times x squared. It's just the stuff inside. 3 cube root, 3 is an odd number, so I don't have these absolute value signs that I have to introduce when I'm simplifying a square root or a fourth root or a sixth root or any other even numbered root. Any odd root, when I do the simplification, it just is what it is. There's only one solution to cube roots and fifth roots and seventh roots. And it's a positive thing if the thing inside was positive, and it's a negative thing if the thing inside was negative. So we don't have to make sure that they're all positive. We're allowed to take cube roots of negative numbers and cube roots of positive numbers, unlike with square roots. So even though it tells us this caveat about x and y can be any real number, we get to say, so that's all right. Regardless of what it is, things still work out fine. I don't have to require things to be positive. So my solution is just 4 times y times x squared.